So after talking to the authors of the paper, I mean, they'll make the code available so I can double check, but they also suggested that I try K13 because um, the IBM Q devices that are available might not be good enough for K14. So we'll try K13, which shouldn't be complicated. I just copied the notebook in here, so I think we can just basically um, with K13, I'll just go ahead with with theta being pi divided by 3, and then we'll create a quantum circuit with 3, and then just get rid of these. I guess that should be enough. So we'll just go like that. Then I think those things, kind of stay the same, right? Those pieces don't change, which is good. They're just um, now this is going to change because here, let me clean up a little bit. So, so this is going to change as well, and but it shouldn't be complicated. So what I will do is, well, with 3 qubits, you don't need an ancillary qubit. So it's actually going to be even easier. And you just need the TOF the TOF S gate in this case. Yeah, so that's actually going to be easier. You just need a TOF S, and so you just need these. And then I think that definitely becomes way easier. And so let me see. That should be. Oh my god, no, that's 3 qubits, and that is definitely 2 exactly. So that looks easier. And so now if we're doing the measurement error correction, we're gonna just do 3 qubits, and we're gonna create a quantum circuit of. So that's the final circuit. The final circuit is gonna have 3 qubits, right? I just need 3 qubits. That's for the whole thing. Do I? Yeah, of course. K13, 3 qubits, because the one is virtualized. And so I just need 3 qubits and 3 classical resistors. And then that's just going to be, to be honest, simple as possible. Just goes like that, I guess, all the way. Doesn't get easier, I think. And zero, 1, 2, that also feeds so IBM Q experience the connectivity, right, of, say, Burlington 0, 1, 2. Yeah, they're connected. So that's not an issue. So I do that. I draw the circuit. Yeah, fairly simple. And so let's give it a shot, or 8,192 shots. Let's see if that works. That can probably be a really short video. Running done, running done, running done. So yeah, that will be one thing. Then I'll compare the code as well. We'll see if that works. But we should be getting something like that here, like we see with the custom simulator and with the other machines. Hopefully. If this is already done running, no, it's still running. And then we'll do the error correction. Let's see if it works well. Still running. It's good. I don't know why would that be the case, but yeah. also I was playing around. I think I didn't record that, but I was playing around with the uncompute again, and I kind of the simulation results don't look good. So I also put it in here as as sort of a feedback. For done 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 perfect. We get the results. We plot them. Not bad. Honestly, not bad. 25%. Honestly, not bad. Now, how are we going to do this? So now Burlington histogram. Burlington properties. We're getting all this stuff here. We're getting the Burlington noise model, but I don't have to because I think I can run it. I can just run that in the Burlington like that. I don't have to simulate that. I could, but I don't have to. I mean, that should give me even a more accurate, right? Say that should give me more accurate calibration, more accurate calibration results. And I'll just print an example. We will see, but that doesn't look bad, honestly. At least for the 111, which is the actual solution we're looking for. But why? Wait a second. Why is the simulator? Something's off in here. Why are those so low? Doesn't smell good. I should probably rerun the whole thing. Anyway, I mean, I'm not suspicious in there. Kind of seems like the opposite than it should be. Why? What have I done? Tough S-gate. Well, I don't need to swap, honestly. But it doesn't matter, right? What am I doing wrong? What is oh, I probably ran it too many times. I probably should just run it like two times. That should probably be enough. Maybe I ran it too much. Let's see. Let's see. Could be that I've run it too much on a simulation. I find it though sad if the publicly available machines are that bad that I can't even play with this and prove and sort of help double check these papers, which are honestly really enjoyed. Yeah, but you play with Orense, and I have access to Orense as well. Yeah, but it was really busy. I actually haven't used Orense because it's too busy. I mean, 101 jobs. Come on. I'm getting this. Okay, now looks good. Now looks good, honestly. The whole thing again. Let's see what we get at the end. It seems K13 could be working. The 000 is pretty low. But here we're like at 23%. And in the paper they get, what do they get? A bit more. Roughly 30%. But they get nicer, more symmetric results. And I don't. But I mean, what are the probabilities really that these two states, for example, yeah, it's being corrected a bit more. But still, this is quite low. I'm quite surprised. It's like 0.27. I mean, yeah. What if we do it like it's supposed to be done? Or look, what if we do it this way? Oh yeah, but noise model. Simply saying noise model equals this. It's roughly the same. Okay. Yeah. Not bad. Okay. Let me go to GitHub. I probably should just should go to the should update that, and I probably should do that like a pro and not just uploading files like that, but using the console. So why not? There's no. Oh, I didn't. So first of all, I want to delete these. Delete these, and I want to upload files, and I want to upload these two notebooks, and I'll do this. And I'll update because I asked in Qiskit in the Qiskit Slack. I just want to make sure I edit the question so people don't complain that I linked, or the link is dead or something. Could be the machines are not good enough for this. K13. This work better. Cool. Yeah, let's see. Oh, it was a short video. So K13 seems to work, or at least seems to be a bit more promising. But it's definitely not, I'm definitely not getting the same results like they do. But they use Orense, so I mean, like, it's so full. Yeah, okay. Anyway. I'll try later, I guess. But here it is. That's the K13 version. Cool. Share those as well, I guess. Should clean that up. Perfect.